One of the cool results of our time together in this video is that in the future, if somebody comes up to us and says, hey, can you tell me about layer 2 switching? The answer that we'll have is absolutely yes. So let's use this as the backdrop for this discussion. This is the icon that represents a network switch, a layer 2 switch specifically. And this switch has 5 ports. Now, some switches have hundreds and hundreds of ports. In this example, we're just going to start with 5. 1, 2, 3, 4, 5. And on each of those ports, these are little RJ45 connectors. That's the name of that typical Ethernet connector that we use to connect to Ethernet networks. And we have a cable that goes to computer 2, another one that goes to the internal server, PC3 on port 4 to the printer, port 5 to a router, and then that router has additional connections out to other networks, represented by this cloud right here. And when a switch first powers up, it does not yet know what the layer 2 Ethernet address is of computer 2 or the internal server or any of these devices because it's just been powered up. But one of the cool things about a layer 2 switch is it likes to learn. And a good question might be, well, Keith, what does this layer 2 switch like to learn? Well, it likes to memorize source MAC addresses. That means if computer 2 sends data into the network, and as part of that, it includes its source MAC address, which is this bad boy right here, the switch is going to say, based on that frame of data that just was received on this port, port number 1, because the source address was this one ending in 778899, I'm going to remember that. This is a little game that layer 2 switches like to play, and it'll go something like this. It says this MAC address, and I'll just put the one ending in 778899 for brevity, is reachable out of port number 1 because I just saw a frame come in on that port, and the source MAC address was ending in 778899. So every time a frame enters into the switch, a frame of data, the switch is going to add that to a little table it has in memory to remember where that MAC address lives, which port that MAC address lives off of. Let's do it one more time for this server. The server has a MAC address ending in 678322. And so when this server sends at least one frame into the network on this port, the switch says, oh, goody, that MAC address ending in 678322 is reachable off of port number 2 because I just saw a frame that came in on port number 2 and it had this MAC address with 678322 as the source. And that process would continue as PC3 and the printer and the router or any other network devices send a single frame of data into the switch. The switch is going to add that to its what's called a MAC address table. Now, one of the questions that might come up as a result of this extra work the switch is doing is, why? Why does the switch want to memorize which MAC addresses are reachable off of each port? And that's because a layer 2 switch has the ability to make intelligent forwarding decisions based on knowing where the layer 2 addresses are and what ports it can use to reach them. For example, if this printer sent a packet into the network and at layer 2 it was destined for the MAC address of computer 2 that's ending in 778899, the switch says, oh, goody, 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 goody. I know exactly where that layer 2 address is, and it will forward it on its backplane over to that port and then deliver it out that port, in this case, port number 1. And the benefit is the switch didn't have to forward that out ports 2 or 3 or 5 or any other ports except for the port where it knew that layer 2 MAC address lived. So layer 2 switches that make forwarding decisions based on MAC addresses, layer 2 addresses, are referred to or commonly known as layer 2 devices. So here at layer 2, the data link layer, that's a very common device that we're going to have is a layer 2 switch that's making those forwarding decisions based on those MAC addresses. And also a common way to refer to the data at layer 2 is to refer to it as a frame. So in the world, most people call the stuff that's coursing through the networks packets, but if we want to be literal and more granular, we could, as we focus on the layer 2 information, call that information or refer to it as a frame of data. So let's imagine that this switch has learned all the MAC addresses off all the ports, port number 3, port number 4, port number 5, with whatever the respective MAC addresses were that it learned from those network interface cards that were sending frames in on those ports. And so for most traffic is going to be switched at layer 2 by the layer 2 switch only to the ports that need to receive that data. Now, there's a couple of exceptions where the switch, when it receives a frame of data, is going to forward it everywhere. Let's imagine that this router is sending in a frame of data into the network, and let's imagine that it's a broadcast. So it's a layer 2 broadcast. And a layer 2 broadcast is 12 Fs, which corresponds in the background to 48 ones. It's a reserved address that simply means everybody needs to see this frame of data. And so when the switch receives a broadcast, the switch is going to forward that frame to every other port in that local area network. Because it could be an ARP request or something else that every other port potentially may need to see. Another situation that can arise is referred to as an unknown unicast. Now, a unicast frame means this frame is intended for one specific MAC address. However, what if the switch has not yet learned which port that MAC address lives on? So in that case, where it receives a frame that's going to a MAC address where it has no clue where that is, it's going to go ahead and flood that frame, meaning forward that frame to every other port on that local area network so that hopefully it'll get to its intended recipient. So my intention for this nugget is to have us learn three basic things. Number one, that a layer 2 switch dynamically learns MAC addresses and what ports are associated with by looking at the source MAC address on every frame that comes into the switch. Secondly, armed with that information, the switch, if it receives a frame going to MAC address X or MAC address Y, and it knows where that port is, it can forward it directly to that port and leave all the other ports alone, not bother anybody else. And the third thing I want to share with you is that a layer 2 switch is one of the most common ways for connecting and grouping devices together on wired networks today. So I hope this has been informative for you, and I'd like to thank you for viewing.